Hello everyone, and welcome to Type-Safe Interfaces with Modern C++, a course by Packt Publishing. My name is Vittorio Romeo. I'm a software engineer at Bloomberg, also involved in Modern C++ training inside the company. I'm a C++ enthusiast, and I write blog posts and articles from time to time on my website, and also participate to conferences and meetups in order to share my knowledge. I also maintain several open source projects and games on my GitHub account, and also like to answer questions on Stack Overflow. Let's see what we're going to learn in this course. We're going to have 4 sections. In the first section, we're going to learn about variants. C++17 introduced a new class called stdvariant, which represents a choice between values of different types. It is very useful to model closed-set polymorphism. In the second section, we're going to look at what the standard provides for variant pattern matching and implement a better alternative with a nicer syntax and more expressive functionality. In section 3, we're going to take a look at optionals. std optional is another C++17 type that represents a value that can either exist or be absent. We're going to take a look at how it works and how we can make your interfaces better. Finally, in section 4, we're going to analyze the relationship between ownership semantics and function parameters. C++17 introduces a new type, std string view, which is a non-owning view of a contiguous set of characters. What's the difference between it and std string, and when is it appropriate to use one or the other? In order to take this course, all you need is some familiarity with C++ 11 and 14 language features. If you want to follow along with your compiler, you also need a modern version of GCC or Clang in order to use C++17 features. However, previous knowledge of the new C++17 language features is not required. We'll learn about them as we go along. These are the goals for the course. First of all, you will understand what algebraic data types are. These include stdvariant and optional. Then you learn to use those classes in order to improve the safety and expressiveness of your interfaces and programs in general. Finally, in the last section, you'll understand the relationship between ownership semantics and function parameter types. Here you will learn about std string view and other lightweight non-owning classes, and when it is appropriate to use them compared to their owning counterparts. The final goal is to allow you to use your new knowledge to write production-ready interfaces that are safer and more efficient thanks to these new abstractions. Thanks for watching. Let's get started then.